Hello class, we're about to start section 9.3, simplifying radical expressions. Square roots of positive numbers. We know that some numbers can look different but have the same value, such as 1.5 we know can be written as 3/2. 4/6, if we simplify that, can be written as 2/3. -10/2, -5, and 35% can be written as 0.35. Now, this is also true of square roots. For example, find the following on your calculator. The square root of 45 and 3 square root 5. If you look at your calculator, you will wind up with the same value here. So, let's take a look here. Okay, now we scroll down here. It says simplest form of a square root. A square root is considered to be in simplified form if there are no perfect square factors inside the square root, there are no fractions inside the square root, and there are no square roots in the denominator. List the perfect squares. We know 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, and 4 is 196, and 15 squared is 225. Now there's also one square that we don't have here, which is very important, which is 0 squared, which would be 0. It says the product property, the square root of AB is equal to the square root of A times the square root of B. Okay, it says here no perfect square factors inside the square root. Write the radicand as a product of a perfect square factor and another factor. Then apply the product property. Repeat as needed. Okay, now it says simplify the following by hand. Now we have to look here. Perfect square and 28. You can look back up at your chart. If you notice, we see the number 4. So we could break 28 down to the square root of 4 times the square root of 7. Isn't 4 times 7 28? Now we know the square root of 4 is 2, and we bring down our square root of 7. So our final answer is 2 times the square root of 7. Now we go here to 80. The highest perfect square in 80 is 16. So it'll be the square root of 16 times the square root of 5. The square root of 16 is 4 times the square root of 5. And that is our final answer. Now for 75, we know 25 is inside of 75. So we add the square root of 25 times the square root of 3, which will give us 5 times the square root of 3. Now we have the square root of 600. We know in 600 we had a perfect square of 100. So we had the square root of 100 times the square root of 6. The square root of 100 is 10 times the square root of 6. And that is our final answer. Now we scroll on. It says the quotient property. We have the square root of A over the square root of B. Now this could be rewritten as the square root of A over the square root of B. Now, it says there are no fractions inside the square root. Reduce the fraction inside the radical if possible. Then apply the quotient and product properties to break up and simplify each radical. Now, this is just a general rule, but we know once we get a number, we need to get rid of this radical off of the denominator. Now it says here, simplify the following by hand. So now we have the square root of 5 over the square root of 36. Now, if you notice here, 5 has no perfect squares in it aside from positive 1. And the square root of 36 is 6. So this is our final answer, the square root of 5 over 6. Now we come here. We have 10 and 64. Now here's the thing about that. We can simplify this, but okay, let's simplify this. 10 and 64 both has 2 in common. So this would be 5, over 32. Now, this is going to complicate things because you're going to have to find a perfect square in 32 and then also get rid of the radical in your denominator. When you could do this, isn't 64 already a perfect square? Yes, it is. So we could break this up as the square root of 10 over the square root of 64. So we will have the square root of 10 and the square root of 64 is 8. And we're done. Now we have here the square root of 15 over 27. Both of these have 3 in common, and neither one of these is a perfect square. So this will end up being the square root of 5 over 9. So now we can simplify this. We will add the square root of 5 over the square root of 9, which will give us the square root of 5 all over 3. And that is the final answer. Now it says, no square roots in the denominator. Rationalize the denominator by multiplying by the smallest factor that will create a perfect square under the radical in the denominator. So here we have a radical in our denominator. The only thing under the radical is our denominator here. So what we have to do is this here. What would make this square root of 7 a perfect square? Since 7 is a prime number, we will multiply our numerator and denominator by the square root of 7. So 4 times the square root of 7 is 4 square root 7. Square root of 7 times square root of 7 will give the square root of 49. Now we know the square root of 49 is 7. So we have 4 square root 7 all over 7. And that is the final answer because we can't simplify anymore. Now we look here, we notice our numerator and denominator is under the radical. So this will end up being the square root of 2 over the square root of 5. But we know we cannot leave the square root of 5, and since this is prime, we will multiply the numerator and denominator by the square root of 5. So our numerator, square root of 2 times square root of 5, is the square root of 10. Our denominator, square root of 5 times square root of 5, is the square root of 25. And this will give us the square root of 10 all over 5. And that is the final answer. Now we go here to C. We have negative square root of 7 over 12. We still do this like we did the other problems, except for we have to carry over this negative sign. So it'll be a negative square root of 7 over square root of 12. Now, the square root of 12 actually has a perfect square in it, which we know is 4. So we have the square root of 7 all over the square root of 4 times the square root of 3. The square root of 4 is 2. So we will have, we need to carry that negative sign over. We have the square root of 7 over 2 times the square root of 3. Now we have to get rid of this square root of 3. So we multiply our numerator and denominator by the square root of 3 because 3 is prime. So we add negative, this would be square root of 21 over 2. Now the square root of 3 times the square root of 3, we know it's the square root of 9. So now we will have the negative square root of 21 all over 2 times the square root of 9 is 3. And we know that 2 times 3 is 6. So it would be a negative square root 21 over 6. Now we come here to D. We have the square root of 9 over 32. So we will have square root 9 over square root 32. Now we know the square root of 9 is 3. Now 32 has a perfect square, which is 16. So we add the square root of 16 times the square root of 2. So we will add 3 over 4 square root 2. Now we need to get rid of this square root of 2. We'll multiply numerator and denominator by the square root of 2. And we will add 3 square root of 2 all over 4 times. The square root of 2 times the square root of 2, we know is the square root of 4, which is 2. So it'll be 4 times 2. So we will add 3 square root 2 all over 8. Now, we scroll down to the next problem. It says, recall, we can simplify a quotient containing a binomial and a monomial by distributing the division, which we have here. This would be 15x over 3 plus 12 over 3. Which would give us 5x plus 4. Another way to approach this division is to factor the numerator, then reduce the fraction. If you look at the numerator, 15 and 12 has 3 in common. We can factor 3 out. That will leave us 5x plus 4 in our parenthesis, all divided by 3. These 3's will simplify out, and that will leave 5x plus 4, which is what we got in the previous example. Now it says write any fraction in lowest terms. Use the property a over a equals 1, where a is a non-zero, to simplify. Okay, now we have 8 plus 6 square root 7 over 10. Now this 10 only can simplify with the 8 and the 6. The square root of 7 will still stay under the radical. So we look here, 8 and 6 both has 2 in common. So that will leave us 4 plus 3 square root 7, and our denominator of 10. Now, we look here. 2 and 10 both has 2 in common. So 2 goes into 2 once, 2 goes into 10 5 times. So we can have 4 plus 3 square root 7 all over 5. And that would be our final answer for A. Now we go here to B. We could factor out 35 and 15 both has 5 in common. So we could factor out a 5. We add 7 plus 3 root 3 all over 45. And 45 and 5 both has 5 in common. 5 goes into 5 once, 5 goes into 45 9 times. So we will add 7 plus 3 square root 3 all over 9. Now we can simplify this even further. We can make this 7 ninths plus, now we know 3 and 9, 3 goes into 3 once, 3 goes into 9 3 times. So this would be the square root of 3 over 3. So 7 ninths will remain the same, but we know we can simplify 3 goes into 3 once, 3 goes into 9 3 times. So this could be our final answer as well. Now we come here to our next problem, which is C. Now you notice here there's no number in front of this radical, but we have this 12. We know we can factor 12 out to be the square root of 4 times the square root of 3, all over 8. So this would be 14 minus 2 square root 3 over 8. Now both of these values have 2 in common, so it would be 7 minus the square root of 3, all over 8. Now we know 2 goes into 2 once, 2 goes into 8 4 times. So our final answer here would be 7 minus the square root of 3 all over 4. So 7 minus the square root of 3 all over 4. Now that is the final answer for C. Now we come to D. It's basically the same thing. We add 6 minus the perfect square, and 18 is 9. We add 2 left over all over 12. So this would end up being 6 minus 3 square root 2 all over 12. Now we know 6 and 3 has 3 in common. So that would be 2 minus the square root of 2 all over 12. And 3 and 12 both have 3 in common. 3 goes into 3 once, 3 goes into 12 4 times. So our final answer here would be 2 minus the square root of 2 all over 4. And that will be our final answer. Now, of course, you can simplify this even further. You could rewrite this, so I put or. You could simplify the 2 and a 4. You could make that 2 fourths minus the square root of 2 over 4. 2 over 4 is simplified to 1/2 minus the square root of 2 over 4. So you can have either one of these answers, 1/2 minus the square root of 2 over 4, or 2 minus the square root of 2 over 4. Either one of these would be acceptable, and we're done.